Hello, welcome to this tutorial on software engineering methodologies. This is Module 1, Unit 1. So we start with what is software engineering methodology? Software engineering methodology is a framework that is used to plan, structure, and control the process of developing a software system. What is software engineering? Software engineering is defined as a process of analyzing user requirements and then designing, building, testing, and evaluating software applications which will satisfy those requirements. It is an engineering discipline and a branch of computer science that is concerned with all aspects of software production. Software. Software simply refers to computer programs, including its associated libraries, data, and documentation such as requirements, design, models, and user manuals. Software products may be developed for a particular customer or may be developed for a general market. It basically may be generic, developed to be sold to a range of different customers, e.g., PC software such as Excel and Word. Bespoke or custom, developed for a single customer according to their specification. Software costs. Software costs often dominate computer system costs. The cost of software on a PC are often greater than the hardware cost. Also, software costs more to maintain than it does to develop. Thus, software engineering is always concerned with cost-effective software development. Software engineering versus popular computing disciplines. Computer science is concerned with theory and fundamentals. Computer engineering deals more with hardware architecture and hardware-software integration. Software engineering, on the other hand, is concerned with the practicalities of developing and delivering useful software. Attributes of good software. A software product should deliver the required functionality and performance. The attributes fall into the following categories. A. Operational attributes. Budget, it must be cost effective. Usability, it must be usable. Efficiency, it must be efficient and not waste system resources. Functionality, it must be functional and serve the purpose for its creation. Dependability, it must be trustworthy. Security, it must be secure. Safety, it must be safe to use. The second category is traditional attributes. Portability, it should be possible to move from one environment to another. Interoperability, it should be able to exchange and make use of information from other software systems. Reusability, it should be possible to deploy software assets on different projects. Adaptability should be adaptable to change in its environment and circumstances. The third category, maintenance attributes. Modularity, it should be divided into components. Maintainability, software system or component should be easy to correct faults. Scalability should be upgradable in order to meet new user requirements. This is the end of Module 1, Unit 1. So we go to Module 1, Unit 2. So in this unit, we start with professional and ethical responsibilities. Software engineering involves greater responsibilities than simply the application of technical skills. Software engineers must be honest and ethically responsible to be respected as professionals. Similarly, ethical behavior is more than simply upholding the law. Areas of professional responsibility. Confidentiality. Software engineers should respect the confidentiality of their employers or clients, irrespective of whether or not a formal confidentiality agreement exists. Competence. Software engineers should not misrepresent their level of competence. They should not intentionally accept jobs outside their areas of competence. Intellectual property rights. Software engineers should be aware of local laws governing the use of intellectual property like patents, copyright, etc. They should always ensure that the intellectual property of employers and clients is protected. Computer misuse. Software engineers should not use their technical skills to misuse other people's computers. Computer misuse ranges from simple misuse such as game playing on an employer's machine to very serious misuse like spread of computer viruses. ACM IEEE Code of Ethics. The Association of Computing Machinery, that is ACM, and the Institute of Electrical and Electronic Engineering, IEEE, have jointly produced a code of ethical practice for software engineers. The IEECS and ACM Joint Task Force on Software Engineering Ethics and Professional Practices was responsible for developing these sets of expected ethical behaviors from software engineers. The expected code of ethical behaviors were listed under the following 8 principles. Public. Software engineers shall act consistently with the public interest. The client and employer. Software engineers shall act in a manner that is in the best interest of their client and employer, consistent with the public interest. Products. Software engineers shall ensure that their products and related modifications meet the highest professional standards possible. Judgment. Software engineers shall maintain integrity and independence in their professional judgment. Management. Software engineering managers and leaders shall subscribe to and promote an ethical approach to the management of software development and maintenance. Profession. Software engineers shall advance the integrity and reputation of the profession consistent with the public interest. Colleagues. Software engineers shall be fair to and supportive of their colleagues. Self. Software engineers shall participate in lifelong learning regarding the practice of their profession and shall promote an ethical approach to the practice of the profession. This is the end of this unit. We go to the next unit, still under Module 1. So we start with software process. Software process, also known as software development lifecycle, is a set of well-defined and structured sequence of stages and related activities in software engineering that leads to develop the intended software product. The software process activities include software specification, software development, software validation, and software evolution. We shall discuss on each of these activities. Software specification. This is the process of establishing what services are required and the constraints on the system's operation and development. Software development, that is design and implementation. This is the process of converting the system specification into an executable system. Software design involves designing a software structure that realizes the specification, while implementation involves translating this structure into an executable program. Software validation. Software validation is concerned with showing that a software product conforms to its specification and that the product meets the expectations of the customer. It involves checking the processes at each stage of the software process. The majority of validation costs are incurred after implementation when the operation of system is tested. The software may be tested in three stages, namely the system component, where each component of the system is tested, the integrated system, some groups of components of the system is tested as a unit. And finally, a whole system where the overall functionality of the system is tested. Software evolution. The aim of software evolution is to implement the possible major changes to the system. The existing larger system is never complete and continues to evolve, thereby making the system more complex. The objectives of software evolution are to ensure the reliability and flexibility of the system. So this is the end of this unit. We then go to the next unit, which is software process models. Software process model. A software process model is a simplified representation of a software process or software development lifecycle presented from a specific perspective. Examples of generic process models include waterfall, evolutionary development, formal transformation, integration from reusable components. Waterfall model. The waterfall model, also referred to as a linear sequential life cycle model, was the first software process model to be introduced. It consists of separate and distinct phases of specification and development. This means that any phase in the development process begins only if the previous phase is complete. The phases of waterfall model include A. Requirement analysis and definition, B. System and software design, C. Implementation and unit testing, D. Integration and system testing, E. Operation and maintenance. Problems of the waterfall model. 1. Difficult to accommodate change after the process is underway. One phase has to be complete before moving on to the next phase. 2. Inflexible partitioning of the project into distinct stages makes it difficult to respond to changing customer requirements. 3. This model is only appropriate when the requirements are well understood and changes will be fairly limited during the design process. 4. Few business systems have stable requirements. 5. The waterfall model is mostly used for large systems engineering projects where a system is developed at several sites. The V model. The V model is software process model where execution of processes happens in a sequential manner in a V shape. It is also known as verification and validation model. A V model is an extension of the waterfall model and is based on the association of a testing phase for each corresponding development stage. The stages are requirement definition, architectural design, component design, implementation, unit testing, integration testing, and system testing. Application of V model. V model can be used when requirements are well defined, clearly documented, and fixed. Product definition is stable. Technology is not dynamic and is well understood by the project team. There are no ambiguous or undefined requirements. The project is short. Disadvantages of V model. High uncertainty and risk. It is not a good model for complex and object-oriented projects. It is unsuitable for long and ongoing projects. It is unsuitable for the project where requirements are at a moderate to a high risk of changing. Once an application is in the testing stage, it is difficult to go back and change a functionality. Waterfall versus V model. Under waterfall, the cost of waterfall model is low and the cost of V model is expensive. Simplicity of waterfall model is simple. Simplicity of V model is intermediate. Flexibility of waterfall model is rigid. Flexibility of V model is little flexible. Its steps move in a linear way. Its steps don't move in a linear way. Testing activities start after the development activities are over. Testing activities start with the first stage. Guarantee of success through waterfall model is low. Guarantee of success through V model is high. It is a continuous process. It is a simultaneous process. It is less popular in software engineering. It is more popular in software engineering. This is where we are stopping in this module. See you in the next module and unit. Thank you for watching.